Alright, let's go. Fucking hungry. Need to cook after this bad. Real hungry. Symbolic constants. Symbolic constants meaning hold. I mean, these would be symbolic constants, right? Excuse me. Well, it does need a fucking data type, right? Boom. Same with names. Same with any named constant. So for a C-style string one, we could have an array of characters assigned my name is or initialized with my name. I like that they're aggregates, so we can just initialize one after. Well, I guess they're not aggregates, but we can use list initialization to initialize one on the next and the next. Cool. C-style string symbolic constants. So we can have a C-style string with the literal, or a const pointer to one. And if it's a const pointer, it can only ever point to the first element in that array. Wait, really? You don't have to dereference color? Really? So I could dereference it Or so standard character output by default, I guess, creates another pointer and steps through till the end. But if we dereference it, then we're only talking about the one element we're pointing to, the one object. Yeah, I could see it being more efficient in this way, because if we create Alex somewhere and then create an array elsewhere and then initialize the array with those values, each character, we have two copies. One somewhere and the other here. Because the array is an array, it is not a pointer. But then here, we have a pointer, and we're simply initializing it with this, which is interesting. We're not initializing it with the address of, but I guess it's just getting the address of it with the address of the string. So it's just somehow it implicitly gets the address of the whole string. What happens if we made it a non-const pointer? Same result, okay. Meaning that instead of creating this one somewhere and creating this one elsewhere, it's the same? Gotcha. That would make sense. And these are not compile time, so it seems like that's true. This is put into memory at runtime, but only in one place. I wonder if it's a do A, do B, and then do C to clean up, or if it's just a do A and then don't do anything else after the check. So is it like A, B, check, and then cleanup, or is it A, check to see if cleanup's needed, and then it continues? Seems like there are two, and then it's cleaning up after. In auto, and then auto, and a pointer to it, which is interesting. So it keeps the pointer, or it explicitly makes it the pointer. And then auto reference makes it the makes it a reference to the C style? But the literal, it's bound to an R value though, no? So we have a C-style array, another, and a pointer to a const character. And so character output is already taught to step through when it receives a pointer to it. If we pass it an entire array or a decayed array, then it will print the whole thing. Actually, it will, in this case, it's printing the address of 9, seems like. You pass it a non-character one, it prints the contents, the address. Makes sense? But if you pass it a character pointer, a pointer to a character, or a pointer to a const character, you're wanting to print a string so it'll continue. Gotcha. Interesting. For example, we have a pointer to Q, or hold on, sorry. We literally just have a character named Q, and we're printing the address of Q. Will it still print Q? Oh, fuck. So what, do we have to cast it to something to get the address? Because the address is a pointer to a const character, which means it's then going to print the value of it. Well, hold. Well, it's printing it like the address as character. Well, I don't know. So it tries to print it as a string, so it prints one thing and then the next. So C-style strings, I think, implicitly end with an null terminator, but the character does not. So it just continues. So it was a Q. Okay. Let's say you're pointed to a character, so I'm going to print you, but then I'm going to keep printing until I get the null terminator. So it is a Q, it just looks weird. This will be different. Gotcha. Yeah, there's always some crazy shit going on underneath inside standard character output. If you want to print the address of a character pointer, static cast it to a pointer to a const void. Pointer to void? So what is the point that we're basically changing the type of, or we're telling standard character output that we're printing this type of pointer, which is not character pointer, and then boom. You could probably do it to other ones too, but const void might make the most sense. But there might be conversion issues there, I'm not sure. Hmm. Hmm. X and then garbage? Yeah, makes sense. Void, a pointer to void. Standard string view, okay. Okay. Tic-tac-toe. Okay, tic-tac-toe, 9 squares. Yep, 0 to 8. I want to see the visual real quick. Nice. Oh fuck, we can make it 2D, that's awesome. Number of indices needed. So if it's one dimensional, we only pass it the one index because it's one dimension. But now we have 2 dimensions, so we need to select how far and how high. Oh, how far? 8. How high? 0. Boom, looks like it's 1D, but it's not because you're using two subscripts. Two D array. So 0, 0, 0, 1, or 1, 0, 2, 0. I'm not sure. I mean, I'd guess 0, 1, 2, 0, 1, 2, 0, 1, 2. 0, 0, 0, 1, 0, 2, 1, 0, 1, 0, 1, 1, 1, 2. 0, 2, 1, 2, 2, 2. Yeah, it is indeed the row. Cool. Oh, wait, hold on. The right is actually the column, really? So it's actually 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, huh? Or 5 by 3. Okay, so the right one is the usual. So it's like we add more subscripts to the left between the identifier and our main subscript, because this is the 0, the 1, the 2, the 3, the 4. But now this is the 0, or well, the 1, 0, the 1, the 1, the 1, 2, the 1, 3, 1, 4. Oh, and then we can have what, a nested if statement to print it or something, right? Or we could say, well, fuck, I don't even know what it would look like if it was. So that's fine. So what is this? 0, 0, 0, 1, 0, 2, and then 1, or hold, yeah. And then 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Let's do, I don't want to do X's. I'll just do this, sure. We could say 4. Y is less than. I guess we don't care about these sides, huh? Well. What if we did an auto, huh? Or we could do. Or we could say. Oh, and for each one of these. So for this one. J-I, right? Uh-oh. Uh-oh. Hold. What if we tried? Oh, so what we need to do is this, and then at the end, so we say we print the row. So we say print row, and then I mean, isn't this printing out the row? For each row, print the row. There's no print columns and print rows. It's just print this row, and then the next row, and then the next row. Okay. And then here we'll just do X, X. Three. There he is. Excuse me. Three by three grid of elements we can manipulate using row and columns, huh? I have no energy right now. I'm not really sure why. Oh, I also do need the light on. That's something that I'm making a mistake about. I think I need more food. I think that's the answer. It has to be. I've only had a thing of ramen and then my breakfast. Yeah, it's not enough for being awake 7 hours. Not for me. Arrays with more than one dimension? Wait, really? So we could do as many as we wanted? And so at first it's this element. It's this, and then it's this. Or, sorry, it's this. And then it's this, and then it's this. So 0, 0, 1 would look like 0, 0, 1. Sequential lists hold. Memory is linear, makes sense. 2 ways, so we could say for the following array. I mean, so what is up? Boom, 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 or is it boom, boom, boom? Is it by row or by column, huh? Oh, here it is. Row major. So it is boom, 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 versus column. Yeah, that would be stupid. Fortran, who's using this? I mean, I guess it makes sense. Well, I prefer this because it's the opposite of it's the second graph. If we have plus plus, plus minus, and then minus minus, and then minus plus. in our case, we're printing this way and then going down. So it makes sense that we would want to do this by row, not column, I think. Instead of saying 1, 0, we just say 0, 1. And it makes sense because that's exactly how it was laid out when we did it earlier. Oh yeah, true, makes sense. So we could say so we can't intuit it? Oh. No deduction. Yo. Okay. Looks like a fucking struct definition. Use nested braces. Are you sure? When using inner braces, their value initialized. Okay. So in case you're missing something, they get initialized with whatever their default value is. That's good. An initialized multidimensional array can omit the leftmost length specification. Oh. So we don't need to know how long it is, we need to know how wide it is. Cannot omit non-leftmost. Nested for. Oh, and I guess it would be easier with a range based, right? Well, no overload. Oh, hold on. Nice. Okay, cool. Oh yeah, we're dealing with the decay here. If we're dealing with the decay, how could we possibly... We can't, that's the answer. Nope, can't do it. So what, do you have to do regular? We'll hold. Oh God. Oh shit. Oh fuck, but the point is it's not the correct size. I'm just gonna do a magic number for now. Oh fuck, makes no difference, huh? Because grid has 9 things, so it's gonna print 9 things for each. I guess it wasn't ending the line either, huh? Oh, true, because it wouldn't be printing the right value. That makes sense. Okay. I was wondering what the hell is happening here. We're not doing... We actually can, huh? We can print the element without having to worry? This might take me time to get. We have the one array, yep. Yep, so we could say yep, well, we're less than the size, print the element in the line, or boom, 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 boom. Oh, well, in each case, we're doing space, 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 and then in the line at the end. Space, space, in the line. Okay. Yeah, I get this. This works. But then here, a double range base. Oh. Really? So for each element of the entire array, for each element in that row, huh? So it actually is sectioning it off as separate arrays, huh? Interesting. So we could say, so for each row in grid, for each column in the row, and then after printing the whole row, still works. Okay. It's just how it's interpreted, I guess. Okay. The range base is interesting. Number of columns, number of rows, product, columns of rows. For each row. Oh, we're initializing it? Oh, hold on. We just have two integers. And we have a 10 by 10, but with no values. And in this case, we're initializing each element. And each element is the product. And then for each one, we're printing the values. We could do this with 4 too, huh? Excuse me. Excuse me. I guess it would just be character, right? Well, we would need the index in this case, right? And we wouldn't have it. Wait. Hold. I knew it was gonna be some crazy shit. Hold. Oh, I guess you could do something like that, huh? Oh, oops. And we're not going through the end of the rows? Are you sure? Oh, true. Oh, so we're ignoring. Gotcha. Otherwise, we get a shitload of zeros here and here. So we're just ignoring those. Okay. Told you. It's like graph 2 right here. Just pretend these guys are negative. Hmm. That's fine. I figured this was going to be tacked onto the end, so it would be XY, but it's not. Which, whatever. Well, let me check something. Bear back. Oh, actually, I'm right here. Here we go. Nice. I don't even have to go to the bathroom to fix my face. Let's go. Okay. C-star multidimensional arrays. Yep. So how does it work for standard array? Because normally we say the type and then this. Can we do multiple? I guess not, huh? There's no standard library multidimensional array class. So then could we have... Oh wait, yeah, we could just have them nested, right? Didn't I've already seen that before. A standard array of standard arrays. Yeah, I tried that a long time ago. Yep. Womp womp. Yeah, let's make one. Let's do array of sure, characters, fine. Hold. Oh, it doesn't have a name. What's the easiest way to type this? I think this. Oh wait, I don't want to initialize each one of these. Are you fucking kidding me? Oh no. For each column in the grid, sorry, this should say row. For each row in the grid, print the column. So at this row, print bop 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 bop. Next row, bop 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 bop. Because we can only print row by row, not column by column. We can't go boom boom and then go back up, print more. Once the rows, once the line's ended, it's over. Finally, I've been waiting for this song for a while. Hold. Maybe it's different now. Because this for each should be for each one of these. Just gonna print it real quick. Can't print either. Why? Oh, this is because we're still on the grid, not the row. I can't assign the standard array to be... I can't print the standard array straight, and I also can't assign one character to a standard array, I think. Yes, because each one of them is of size 10, I think. Yeah. We can't assign to it in aggregate, maybe. Oops. Excuse me. Boom. Oh yeah, it's true. We have double braces. I don't remember why. We did double braces before, I think, when we were using deduction. Isn't that right? Standard array of standard array int, but those are specified. I don't know if we need the double braces here, do we? We do. Oh no. Because otherwise it's saying assign this entire array this. So initialize this thing here. It's not going to think, hey, this array of 3 guys, each one of you is this. This is not the array's initializer. This is. So this initializer of one, two, three in a hole initialize it with this thing. I think it's when we're I think this was for class objects. When we were initializing, when we had a standard array of class objects that were a standard array of aggregates, then to initialize each aggregate, we have to say not only that aggregate is in braces, but the grouping of aggregates is also in its own braces too, to say that I'm initializing you with this whole thing of separate aggregates. Something like that. It's part of the retardation of CPP. Of class types, yep. Oh, there's the point. So instead of, because these are classes, instead of saying standard array, this guy, standard array, this guy, standard array, this guy of 4, this guy, of 4, this guy, of 4, this guy, we can put the entire thing in braces to not have to do that, basically. Well, yeah, I mean, now if we're looking at it like this, then sure. I mean, really what's happening here is we're saying it's... So we are saying that array has 3 rows and 4 columns, but normally we say 3 rows, 4 columns. In this case, we're saying it's of 3 rows and each one has 4 columns. I almost like this more, but I don't know. Ow. Ow. Okay. Yeah, we already did that. Sure, we could do that. What's an example? Hmm. Inventory, maybe? Fuck, these have to be... Hmm. I don't know if I want to do that. Sure, maybe. Sure. But the passing is annoying now. Oh wait. Hmm. So the passing isn't happy. Oh, duh. Because this wasn't taking a reference, so it didn't update anything. This is just an empty guy. That's why when it prints, the size looks about right, but it's just empty. Boom. I was like, it should be working. It's just an issue of how I was passing the information like an idiot. Bro, what happened to your syntax, man? Make them easier with alias templates? Oh, god damn. I mean, the yuck part is just, well, an alias template, huh? So we need a type name. And what, 2 integers or something? And columns int rows, maybe? Or int rows int columns. And then using array2d as a standard array of type, or well, a standard array of standard array t's with columns. And how many of them are? There are rows. Bibbidi bop. Now is this just problem here? I don't know if this works. No. Well, if we did that, if we made this an array 2D, characters, and then it works. It's kind of gross though. Yep, it does indeed need all these, huh? Use array2d int 34, wherever we want that. Instead, we could do an alias template. We don't have to specify the types in the uses. I mean, I guess that's the point. If we want something that's able to handle a standard array of different types and different lengths, then we have to make a fucking alias template. And we have to make function templates to handle the different versions of the alias it gets. I mean, I don't even think it's significantly better. I mean, it's better. Sure. Well, I mean, the point is so we can reuse it, so we don't have to. We need a template version. We need some generic shit. That's the whole point here. We've put ourselves in a position where we need some templates. So, I guess so. Okay, we're done. Done for now. More tomorrow.